Hello, welcome. Want to handle question number 7, a Form 2 topic, and curved mirrors. The curved mirrors, and under curved mirrors, that is reflection. The curved mirrors, and we have two types of mirrors, or two types of curved mirrors. That is the concave and the convex. Concave mirror, that's how it looks like. Convex, you can have it that way. Now in this question, this student holds a convex mirror. Its focal length f is 20 centimeters, and the student stands 1 meter away from his face, meaning that he's holding the mirror 1 meter away from his face. So we want to state the characteristics of the images formed by the mirror. If we look at the diagram, even before we give the characteristics, so just by sketching, this is the pole of the mirror. Now that is our f, which is 20 centimeters. So our f, that is the focal length, that is 20 centimeters. Now 1 meter away from his face, that is approximately 100 meters. Let's say, just a sketch, let's say that is 100 centimeters. So this is the student holding the mirror. Therefore, just by having the ray diagrams, you can see at that particular point the ray seems to be coming from our f at this particular point, which is virtual, and again our c will also be virtual. For this kind of a mirror, we have virtual focal length and virtual center of curvature. So we can have this one, so it is reflected. Then we can have this ray that will pass through, so at that particular point that is dotted, so that is ray. Using the law of, or the principle of reversibility of light, so on the same path, so the ray traces its own path. So you find that the image is formed between the pole and the virtual principal focus. Now you find that at any given point, the image characteristic of the mirror at that particular point, we can say, one, the image is diminished. The image is diminished, meaning that it's smaller than the object. Two, the image is virtual. Three, it is erect or upright. The image is diminished, virtual, and erect. That's the question. Again, on the same part, you can still be given a question which still looks at reflection, which is a question in Form 1 of the 844 system, where the length of a pinhole camera is 20 centimeters. Determine the height of a building 30 meters away from the pinhole camera, which forms an image 2.5 centimeters high on the screen of the camera. Now, this question is again under reflection, rectilinear propagation of light in Form 1. So pinhole camera, if we have a sketch, so this is the pinhole camera, and we have an object 30 meters away, which is 3,000 centimeters away. So that is the object. Then this becomes the screen. That's where we have the screen, and that's where we're going to form our image, meaning that the image distance for our case is 20 centimeters. The object distance, which is our u, that is 30 meters, 3000 centimeters. Then the height of the image is 2.5 centimeters. So we know that linear magnification m is given as v over u, which should also be equal to the height of the image over the height of the object. The image distance over the object distance should be equal to the height of the image to the height of the object. Therefore, substituting these values here, our v is 20 centimeters, our u is 30 meters, equivalent to 3000 centimeters, equals to hi, which is 2.5 centimeters over h naught. Therefore, at that particular point, h naught be given as 2.5 multiplied by 3000 divided by 20. So you can see at that particular point, so that is by 1 by 15. So we have 25 multiplied by 15. That will give you the height of the building, and they're not very specific, which you can still give it in centimeters, or you can convert it to meters, depending on how you are going to have it. But I believe it is doable and you can do it. So this one should give us 375 centimeters, which is equivalent to 3.75. So we can convert it and say that our h naught is 3.75 meters. Thank you so much. We will still look for more of these questions.